All right, this is Honors Algebra 2 Pre-Calculus. We're doing 12.3 in Algebra 2, which is box and whiskers plots. So a box and whiskers plot is drawn on or above a number line, and there are 5 really important values in the data set that we use to construct the plot. So there are 2 ranges from the data that's also pretty important when we're plotting. So let's walk through that. So in a data set, the maximum is the largest value in the data set, right? So max. The minimum is the least value or smallest value in a data set, so min. The median, which is also called the second quartile or Q2, we'll talk about that in a little bit. That's the median of the data set, meaning physically the middle number if you list the numbers in order, or if there are an even number of values, the average of those middle numbers. The first quartile is the median of the lower half of the data. So if you only take the data on the bottom half and find its median, that would be called Q1, or the first quartile. The third quartile would be the median of the upper half of the data. So all the data above the median, if you found the median only of that half, that would be called Q3, or the third quartile, or sometimes called the upper quartile, right? So, so we have range, which is, you can see here in green, is the max minus the min. That's called the range of the data. And then the IQR, which is called the interquartile range. This is the upper quartile minus the lower quartile, or the third quartile minus the first quartile, right? So again, you can call this one the upper quartile and this one the lower quartile as well. All right, so why are they called quartiles? Well, they're called quartiles because exactly 25% or 1/4 of the data falls in each of the regions between those quartiles, right? So 25% of the data would fall between the minimum and quartile 1. 25% falls between quartile 1 and quartile 2, or quartile 1 and the median. 25% falls in this window between Q2 and Q3, and 25% falls between Q3 and the max, right? And so I drew you 3 different box and whiskers plots here. Not really 3 different box and whiskers plots, really, but 3 different representations of the way the data is going to look, because these don't have boxes and whiskers, just to show you that sometimes the data is really evenly spread out. It's pretty even in this top one. Sometimes the data is not evenly spread out at all, and you'll have a really long branch in this direction. So just to show you, that's kind of the idea. So let's walk through how we make a box and whiskers plot. So drawing the box and whiskers, right? So here's how we draw the box and whiskers. Basically, what's going to happen is we are going to find all of these values that we discussed, right? So you're going to find all the values that I listed here on the first page, right? Once you find the min, the max, and all 3 of those quartile values, Q1, 2, and 3, you're going to draw lines, right? You're going to draw lines at the median and at both of the quartiles. And then you're going to use those to make a box, right? So that's the box part of box and whiskers. And then the whiskers go from the upper quartile to the max, or from the lower quartile to the min, and those are called the whiskers. So this piece is called the box. Notice that the box coincides with the interquartile range, and these pieces are called the whiskers. So that's a whisker and that's a whisker. All right, so that's how we draw a box and whiskers. So we find all of these values, right? We find the values we just discussed, and then we go ahead and draw like this, right? So let's go ahead and do some examples. This is not a really difficult concept, because basically you're doing median, median, median. Like when you hear box and whiskers, your brain should just be like, so many medians, right? All the medians, because it's the median of the entire data set, and then it's the median of the top half and the median of the bottom half. So let's go ahead and walk through this. So we're going to create a box and whiskers plot for the data. We're going to find the range and the interquartile range. Now I already put this in order for you because frankly, the last video we had to put so many things in order and it was so exhausting, so we're just not going to do that. So let's count how many points we have first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so there are 11 points, okay? That's worth noting because 11 is a nice number, because since it's odd, it means that the middle value will be all by itself. This is going to be my Q2 or my median, right? So then I have this top half of the data. Now the Q2 doesn't count in that top half, right? So this is the upper half, right? And I also have this lower half down here, right? This is my lower half. So I'm going to find the median of the upper and lower parts. Well, the lower part only has 5 data points. So if there's only 5, the median is the middle. That's my Q1, right? If there's only 5 points in the upper half, then my median is the middle value. So that's my Q3. And the max and the min are pretty self-explanatory. They are the values at the top and bottom. So what I'm going to do is I'm going to make a number line that has everything evenly spaced, because it is going to matter what my distribution is when I draw this. And I probably should have just taken a stock number line from the interwebs, but I didn't, so here we are. So I need numbers from 1 to 18. So I'm just going to start at 0 and go to 20 because that pretty much covers my needs and it's easier, right? So if I cut 10 in half, I get 5. If I cut 10 to 20 in half, I get 15. And then to get 5s, I cut the middle out and then cut those 2 pieces in half. Cut the middle out, cut the 2 pieces in half. As a math teacher, you cut things into 5s a lot. Okay, so I'm going to go ahead and put these values here. So I did the Q2 in red this time, so I'm going to go ahead and put, hey, there's my median, there's my Q2, right? My upper quartile I did in blue, and that's at 15. You don't have to color code, I just thought it might make it easier. And my lower quartile is at 6. So that's the box, right? So the box that we talk about when we say box and whiskers, this is it. That's the box, right? And then the whiskers are going to go down to 1, which is down here, and up to 18, which is here, okay? When I'm asked to find the range is going to be the max, which is 18, minus the min, which is 1, so that's a 17. The interquartile range is going to be the upper quartile, which was 15 in blue, right, minus the lower quartile, which was 6, so that's going to be a 9. And those are the values I was asked to find. All right, so that's how we draw a box and whiskers plot. It really is just about the median over and over and over again. So go ahead and give this a try. Again, I did put the data in order because we spent a lot of time in the last video sorting data. So first thing, count all your data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So yet again, yay, we get an odd number, which is super helpful because odd numbers are just nice because you don't have to worry about averaging anything to get the median. So if it's 15, I need 7 on each side, number 8 in the middle. 1, 2, 3, 4, 5, 6, 7, 8. Let's double check. 1, 2, 3, 4, 5, 6, 7. Yep, that's 8. So this is my Q2, right? The top half of the data has 1, 2, 3, 4, 5, 6, 7 points. Well, that's also nice because since this is also odd, it's just going to be the middle value. I don't have to worry about average anything. So there's my Q3, right? For my lower half of the data, the middle number is the 15. That's my Q1. And then the max and min are pretty self-explanatory, right? So looks to me like my number line is going to have to go from 10 to 40. Remember, I do need some sort of a consistent scale. You don't have to scale by ones, right? You could. So I could say, hey, cool, this is 20 and this is 30, right? And I could leave it like that and then just kind of estimate where values are. That's fine. Or you could go by 5s, right? If you want to go and break everything down and actually go by ones, that's absolutely fine. You could approximate it from this value. That's fine. Especially because other than 32, all of them happen to be 5s, right? So my minimum value was a 10. My maximum value was a 40. My lower quartile was a 15. My Q2 was a 25. And my Q3 was a 32, but I can estimate 32 from what I've got. So here's my box, right? The box goes around the interquartile range, and here are the whiskers, right? I was asked to find the range. Range is always just max minus the min, so that's the 30. And the interquartile range, the IQR, is going to be the 32 minus the 15, so that'll be a 17, and that's it. So when a value is less than Q1 minus 1.5 of the interquartile range, or greater than Q3 plus 1.5 times the interquartile range, the value can be called an outlier for the data set. So a couple of videos ago, we did a thing where I listed all of the hypothetical ages for people in our class, and almost everyone was 14, 15, or 16. There were a few 13-year-olds, and then there was me rocking a solid 41. I'm absolutely an outlier for that data, right? The range, the interquartile range is probably really small. Like we could go back and look at that data, but the interquartile range is probably somewhere in the 14 to 16 range, meaning it's a range of about 2, right? Like 16 minus 14. And me, I'm several multiples of 2 away from that median, right? I'm really, really far away. So, and I'm really, really far away from the upper quartile. So let's go ahead and walk through this. Basically, you can kind of visually see if you have outliers because what will happen is you have a really long whisker relative to the size of the box. So the box might be 5 units in either direction or might be a total of, like, let's say 10 units long, and then you might have a whisker that by itself is 15 units long. A really long whisker usually indicates an outlier. So let's go ahead and create a box and whiskers and see if there are any outliers in this data range. Now this one's not in order. The first thing I'm going to recommend that you do is put it in order. So 3, 12, 17, 18, 23, 25, 26, 28, 30. Right, so the first thing I'm going to do is put them in order. and count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So since there are 9, right, my Q2 is in the middle, but now these are going to be a little harder because since there are 9, there is no middle. Like this is the bottom half. I'm going to have to average these two. So what's going to happen is my Q1 is going to be 12 plus 17 divided by 2, right? So I'm pretty sure that that's going to be a 14.5, right? Because that would be a 29 divided by 2. And the same thing's going to happen with my upper quartile, right? My upper quartile, because this top half has 4 terms, right? I'm going to have to average these two, and conveniently when you average a 26 and a 28, you just get 27. So Q3 is 27, right? Because that's a 54 divided by 2. So here's what I know. I'm going to go ahead and draw my box and whiskers. I need to start at 3 and go up to 30. So we need from, I'm going to go 0 to 30 because that seems a lot easier, right? And then this is my 10 and this is my 20. And again, how much you want to scale your axes is kind of up to you. I think you could easily just go by 5s and not be super miserable about it. So seems to me that I have, here's 3, right? Q1 is at 14.5, which is kind of there, right? That's my Q1. Q2 is at 23, which is sort of there. 27, my bad. Let's fix that. That was a little bit 27, right? And then 30. So here's what you're going to notice. This data is definitely skewed to the bigger numbers. See how there's a very long whisker here and a short whisker here? It's very likely that 3 is an outlier, right? It's very likely that that number at the end is an outlier. So we can actually check and see if it's an outlier, right? So basically anything, so remember it's Q1, right, minus 1.5 times the IQR, right? That's the cutoff to be an outlier on the bottom end. Well, Q1 is a 14.5, right? Oh, and we should probably find, I don't know if I asked you for it, but you should find the range in the interquartile range. So the range is pretty simple. That's a 30 minus a 3, so it's a 27. The interquartile range would be the 27 minus the 14.5, which I think is going to give us a 12.5. So basically, 14.5 minus 1.5 times a 12.5 is going to give me an outlier. So if I do 14.5 minus 1.5 times 12.5, right, so I get that that's not actually enough to be an outlier, right? Because in order to be an outlier, essentially it would have to be even farther. So it's not an outlier, it's pretty far, but it's not an outlier. So, so 3 is not small enough to be an outlier, right? And then in the other direction, right? So in the other direction, Q3 plus 1.5 times that interquartile range, right? So that would be, Q3 was a 27, right? Plus 1.5 times the 12.5, right? And if we do that, we get, so I'm probably gonna, it was 27 plus 1.5 times 12.5, and we shouldn't have one in that direction because that's not the direction where we have the long whisker, right? So that's going to be a 45.75. So there's definitely no outliers in that direction, right? Because 30 is smaller than that, and 30 is the biggest value. So 30 is smaller than 45.75. So there's no outliers in either direction. But again, 3 is getting kind of close because that whisker's pretty long. So if we were to look at a box and whiskers, like I said, of the data with my age relative to all of your ages in class, you'd find that there's definitely an outlier. So go ahead and do the same thing here. Let's see if there's any let's do a box and whiskers and see if there's any outliers in the data. Again, the outlier has to be a pretty significant difference relative to the size of the box. So the first thing you're going to want to do is put your data in order. So I see I have a 5, 2 10s, 15, 20, 25, another 25, a 30, a 35, and a 60. All right, cool. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the first time that to find the original median, I'm going to have to average them, right? So, so 1, 2, 3, 4, 5. These two are going to get averaged, and my Q2 is a 22.5. Now, what's interesting is that means that my median is falling in the middle. So that means that both 20 and 25 count in the bottom and the top half, right? Like, so they're actually part of that half because neither of them is actually the median. So that makes these halves easier because that means there are 5 terms. So my Q1 is 10, and my Q3 is the 30, right? So my range is 60 minus 5, which would be 55. My inner quartile range, which is going to matter for finding an outlier, is 30 minus 10. Sorry, I got ahead of myself, which is 20. When I draw my box and whiskers, I need numbers from 5 to 60, so I'm just going to go 0 to 60 because that seems easier. So here's 0 and 60. Again, that's a lot of numbers to cover, right? There's 30, so if it's too many numbers, then you could just go by tens and you can kind of eyeball where things are. You're not really graphing something like this by hand. If it were ever really important data, you would, be doing it on a computer. So I have 5, a 10 is my first important number. A 22.5 is somewhere around here. There's 30. And then 60 is all the way up here. So again, if there's an outlier, it's going to be the 60. You can see that that's the long whisker. Whether that whisker is long enough to actually be a mathematical outlier, well, that's the question, right? So on the bottom end, I can tell you right now we don't have an outlier because look how short that whisker is, but we can still check in case, right? So Q1, which was a 10, minus the 1.5 times 20, right? That's going to come out negative, right? So that's definitely going to be a negative number. So 10 minus 1.5 times 20 is a negative 20. So there's definitely no outlier on the min side, right? On the minimum end, there's no outlier because the smallest number is 5, and 5 is definitely bigger than negative 20. Q3 plus 1.5 times 20, right? Well, that would be a 30 plus 30 plus a 30, right? Which should be a 60. So we have 30 plus 1.5 times 20, just double checking that my math is right, and that's 60. So now we have to go back to and double check if an outlier is greater than that cutoff or the same as that cutoff, because I don't remember. Okay, so if it's greater than this value, so technically 60 is not an outlier, but it is literally right on the edge. Just barely not an outlier. Right? So anything higher than 60 would have been an outlier because 60 is the cutoff, right? 60 is the number we have. If this had been like a 61, then it would have been an outlier. So had this been a 61, there would be an outlier. Had this been a 60.2, it would have been an outlier, but here it's not. So let's just real quick walk through how we would do box and whiskers plot on our calculator. So I'm going to walk you through it real quick so that you're aware of how it works. So I'm going to use the data from E1. So what I'm going to do, right, I'm going to go to Stat, I'm going to go to Edit, and I'm going to pick list 1. Now, I've already put the data in here, I think. 1, 5, 6, 8, 8, 11, 12, 13, 15, 17, 18. So I go all the way down. You can see I did it right here. I'm going to go, after I do Stat Edit and put it in list 1, I'm going to go to Y equals, and I'm going to make sure I don't have any graphs on. What I mean by that is if I had something in here like this, I want to see how that's on. I want to go over to that and turn it off. Now, I didn't have anything in there, but let's say I did. That's what I want to do. And then I'm going to quit out. Now I want to go to Stat Plot. So I'm going to go to second, Y equals, and I'm going to pick plot 1. I'm going to turn it on, right? And you can see that I turned it on. I'm going to scroll over, I'm going to scroll down and go over to the one that is definitely a box and whiskers, right? Which is this one. I'm going to pick list 1 because that's the list I used. If you used a different list, that's fine. Pick a different list, right? And then I'm done. And then when I hit zoom, now watch, if I just graph now, you're not going to see what I want to see, right? So the reason I added this where you want to press zoom stat is because this is going to graph it not where you're usually seeing your window, right? So you're going to do zoom and then stat, which is zoom 9. And there's your nice happy box and whiskers. Now an interesting thing is that if you hit trace, it'll tell you all your values. It'll tell you your median is 11. It'll tell you your quartile 1 is 6. It'll tell you the min value. So that's pretty cool, that if you hit trace, you can use the left and right arrows to see all those values. So that's the gist of this, and that's 12.3.